Okay, the problem on the board tells us to identify a sequence of transformations that'll turn figure B into figure A. Alright, first thing, we should be pretty obvious that figure A is much bigger than figure B. So the first transformation we're going to be thinking about is a dilation, specifically an enlargement. We need to make figure B larger. But we need to know a scale factor. If we're going to talk about a dilation, we got to think about how much larger. 2 times larger, 3 times larger, 2.5 times larger. And the way we find our scale factor would be to compare corresponding sides of figure B and figure A. Or if you wanted to, if you don't want to compare corresponding sides, you could actually compare some of the coordinates of the vertices. You could compare the x coordinates of these 2 points, or you could compare the y coordinates of these 2 points if you wanted to. Either one would get you an accurate scale factor to use your dilation. Now, when we set up a scale factor, remember it's always got to be the image, the one you're going to, over the original. So we're going to take the side, let's go with the side length of trapezoid A. Let's compare side lengths. So if we go with the long side of trapezoid A, which up here we've got a y coordinate of 4, and here our y coordinate is -2. So let's see, we got 4, 5, 6 units. The long side of side A is 6 units. And if we're going to set up our, make our ratio, so it's going to be 6 over, and let's compare the corresponding side on trapezoid B. We're going from a y coordinate of 2 to a y coordinate of -1. That would be 1, 2, 3 units. Okay, so the corresponding side, side A, 6 units, side B on trapezoid B is 3. 6 over 3 equals 2. That is going to be your scale factor. So your scale factor is 2, so we know that trapezoid A is 2 times bigger than trapezoid B. And the way we would represent that transformation algebraically, the dilation from B to A, we would say that coordinates xy will become 2 times x, 2 times y. So that's how you represent your transformation of your dilation of B to A. So now we've got trapezoid B would be the same size as trapezoid A, but it's not necessarily going to be in the same location. We're going to have to do a little bit, but we're going to have to probably make another transformation. But where exactly would this trapezoid be once we dilate it? Well, if we apply this rule to any one of our coordinates, and let's pick this guy again. If we take this point, which had coordinates of -1, 2, so our coordinates are -1 and 2. And if I apply the transformation of multiply your x and the y by 2, well, that would become -2, 4. So once we dilate trapezoid B, this point here would end up being at the coordinates -2, 4. It's going to be right about here. Okay? So this point, when we dilate, ends up being here. And I want it to be here. So we need to move it over. Let's see, we've got a x coordinate of -2, and here we have an x coordinate of 5. So from -2 to 5, that's a total of 7 units. I need to move the whole trapezoid 7 units to the right. And that means each one of the x coordinates would increase by 7. So our next transformation would be, algebraically, our coordinates x and y would become x plus 7y. We would add 7 to each one of the x coordinates to translate the trapezoid 7 units right. And that's how we could transform trapezoid B into trapezoid A. We would first dilate it by a scale factor of 2, make it twice as big, and then we would slide it 7 units to the right. Okay, for now, I want you to try and go the opposite direction and see what you would do to turn figure A into figure B.